How was spring break? Boring. Boring. Okay. All right. Just hung out. Did a bunch of math. Not really. Yes, sir. Question. Oh, it's business. It's the only thing I can say. Business. Trade. Good question. That's ultimately that's a math question. There's a budget. Right. It wasn't for the picks. It was to get rid of his contract and then have more money to spend on who knows. But you know. All right. So today is a special day in the world of math because today is March, the third month, 14th day. It's 314. So happy birthday is coming up. But 3.14, if you've heard of that before, it is pi. It's an approximation of pi. So people call today Pi Day because it's 314 for 3.14. And wow. Wow. Yeah, Pi Day on a Friday would be cool. But now usually Pi Day is on spring break. So this is one of those special years where it's during a school day. So I thought to myself, I should bring everyone a pie. But then I thought about some of the way y'all act in my class, and you're late to my class, and you say crazy things. So I'm like, maybe not. Costs a lot of money, like $5 a pop at least. It's like it's a lot of y'all, it's not a lot of me. So I was like, you know what? So then they have oatmeal cream pies, those little So I was like, man, I could get everyone one of those. But then I thought further, and I thought, not everyone deserves the oatmeal cream pie, and I'm not made of money. I'm not made of money. So as I was thinking and eating a lot of pie to myself, I was thinking maybe people who got an A in this class should get a pie. I think so today A's get pies. That's all I'm saying. So it's not worth it. You can buy 24 with $10. After this, I'm gonna get them. So all right. So maybe not third 9 weeks, but maybe fourth 9 weeks you can earn a pie, but it won't be Pi Day. So okay, you can always buy one. Yes. Okay. Now real quick, in the back. So it is the last 9 weeks. Some would call it the last quarter. So like in any game or anything at all, you want to finish strong. Especially some of y'all, if you barely passed or if you passed, cool. Make sure you pass again. I would like for you to shoot higher than 70, right? But some of us, and I will talk to you today or tomorrow, who did not pass, your goal is no longer 70. You need to get higher than that to average it out to get credit, okay? So we will talk. We don't need to talk now, though, okay? So check it out. Very important that we finish strong. That's all I can say about that. We only got 9 more weeks-ish. And then hopefully you move on to the next subject and the next teacher, right? Okay. So now I asked you to find pi. Pi, did you know, is an irrational number. It's irrational because it goes not only does it go forever, but there's no pattern. Okay. Yeah, in fact, you can make a lot of money if you can figure out what the pattern is, but there's no real pattern. Okay. For real. Now, say what? There's nothing to solve. What do you mean? Well, you find pi using this formula, C over D. Okay. Now, you take any circle, anywhere. Okay. Every circle has a distance around the edge, which is circumference, and then from one edge to the other edge through the middle, that's the diameter. Okay. So radius is halfway, but diameter is all the way across. Cool. So now I'm telling you, every single circle ever, that's a real circle, not a oval or something weird. If you take the circumference and divide it by the diameter, you will always get pi. Okay. So pi is not made up. It's not some like nerd in a basement thinking, I'm going to think of a number. No, it's like it occurs in nature. Okay. Anytime you see a circle, there's pi. When you eat a pie, there's an actual pie in there. Okay. You look at the clock, there's pi there. You look in someone's eyes, there's pi there. Okay. Pi is everywhere. Math is everywhere. Okay. Now.
Did you guys try heat? You ain't even share?
Okay, so, and Hiram made a large bowl, okay, in this ancient text, Hiram, some random dude, made a large bowl, 10 cubits from one rim to the other, so it goes straight through the middle, that's the diameter, okay, so I told you, diameter is 10 cubits, okay, and then it says 30, it did compass around it, so along the edge, that's the circumference, is 30 cubits. Now, do y'all know what a cubit is?
No.
Okay. Now, before we had cool rulers and tape measures, okay, people would measure with this thing. Okay. So even though everyone's arm's different, it'd be like from here to here, it's about a cubit. This desk is about a cubit. Okay, so 18 inches. Okay, give or take. And then people would also measure with their hands. So a hand's breadth is literally this distance from your hand. Okay, about 4 inches. Exactly. So it's not perfect, but it's kind of closer than like a bear paw. I don't know. So all that to say, cubit are 18 inches, a hand breadth is 4 inches. Now here's the deal. If we just hold on. If you use this C and this D, okay, if you use 30 and 10, and I calculate pi, so the circumference is what again?
30 cubits.
30, thank you. And then the diameter is what?
10 cubits.
What is 30 divided by 10?
3. What?
3. Okay? It's all good. Now, listen, please. So 30 over 10 is 3. Now, here's the question. Is 3 pi? No. Thank you. Now, in middle school, your teacher may have, if you've ever done this before, they may have said, 3's fine. No. Now, it does round down, but it ain't exactly pi. Pi is technically 3.1415, blah, 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 right? So here's the deal. Some people, riding in on their high horse with their nose in the air and boogers in their nose, are going to be like, look, this is whack because this ain't exactly pi. Fair enough. Fair enough. Now check it out. If you keep reading though, it says it was a hand's breadth thick. Now, here's a picture of the bowl. Oh look, pies. Here's the bowl. Now, if you take off 4 inches from each side, okay, if you do the calculations and if you account for what cubits are, so those 30 cubits on top, I'm going to multiply them by 18 inches to get inches. On the bottom, I'm going to take those 10 cubits times 18 inches to give me inches. But what am I going to subtract on each side? 4 and 4, because I'm getting the inner circumference and the inner, okay? So I'm going to subtract 4 plus 4, total 8. So I'm subtracting 8 from that diameter on the bottom. And I'm going to cut to the chase. If you plug that in your calculator, you're going to get 3.139. Now you tell me, is 3.139 dang close to 3.14?
No.
It is, okay? Now, what does this all just do? Just to show you something cool, kind of. But also, pi is found in ancient texts from long ago. Also, before then, because pi was not made up, it is a naturally occurring thing, okay? There are lots of cool natural numbers, okay? Golden ratios, patterns in nature, pi, all this stuff. Math is actually, when you look close, it's pretty cool, in geometry. But of course, we're not in geometry, but that is my warm-up for today because it is Pi Day, and that's how we celebrate. And without further ado, some people have earned a pi. All right, so let me... Hey, 4th 9 weeks, I'll bring out brownies. Yeah, if you get an A, I'll give you a brownie. The best kind. Do you want me to make it? You want me to make it homemade? Homemade. All right. What? I have no idea. All right. So you have earned a pie. Yay. If you don't like it, share it with someone else.
I'll give you $5 for that pie.
All right. You have earned a pie. Congratulations. You have earned a pie. Congratulations. All right. And you have earned a pie. Congratulations. All right. All right, here we go. Hey, what are you doing? There we go. So now what we're gonna do? Hey, we're doing notes. Yeah, it's gonna be hard to see. I promise. There, one for. Okay, here we go. Okay, here we go. All right. Can I get everyone's attention, please? So, we are going to hit the brakes real hard because we're not talking about circles or pi anymore, and we got to talk about rationals. So, here we go. Rational functions. Ironically, we just talked about an irrational number, and now we're talking about a rational function. Okay. Ironically. Okay. Real quick. Okay, you can write this down on the lines at the top. What is a rational function? It is a function whose rule can be written as a ratio of two polynomials. The parent function is f of x equals, and this is important, 1 over x. The x is below. Okay? Did you get one? Did y'all get it? Yeah, where's yours? Right here. You can write it down. Never know. Um, 330, 345. I'm not in charge of that. I'm just got to get picked up. So, yeah, and our cars are, yeah. So she's gonna pick me up and, right. She told me to remind her at 3, and then she'd have to come from downtown. So, yeah. So we're good for a little bit. I'm gonna, yeah. There we go. So, everyone listening. All right. So, rational function is a function whose rule can be written as a ratio 1 over x. If you still need this, no, but it's right next to you, kind of zoomed in. If you turn, though, tell me about it. Well, I broke mine and then had surgery. Oh. Okay, so here we go. Oh, you're right. You're right. I went back. Okay. Yeah, so when I was a freshman in high school, I had major back surgery. Broken disc, broken vertebrae slipping disc. Yeah, but it was continuing. No, this was like last couple of years. This was 2001. Yeah, yeah, it kept slipping and slipping, slipping. So. Wait, what? Yeah, 2005 I graduated. 35. Goodness gracious. Ugh.
He's 27. Why you did stretch or what?
Well, it could have been playing football, could have been jumping off houses, doing silly stuff you do when you're a young guy. You're like, I'm invincible, I can do whatever, you know. I don't know.
I was squatting 405.
I didn't need to try, so, you know. I have stories, but I will not tell you. That's right. That's true. What? Of course.
You actually did? I didn't go.
I went. I had to.
Yeah, I didn't even go to home.
It was great.
I've gone out
No.
3 years in a row with nobody.
All right, everyone listen. Next one. Okay, so there it is. Now, ladies and gentlemen.
I wasn't done.
So, ladies and gentlemen, vertical asymptote, horizontal asymptote. I know we've said this word before when we did exponentials. I'm going to reintroduce it. Okay, it looks weird. Asymptote means you can't cross the line. So look, see this green line up and down? This will get close, but never cross it, never touch it. This red line horizontally, it's going to get close but never touch it, okay? Like rules, okay? You can get close to it, but don't cross the line, okay? Maybe a bad example for some of us, but nonetheless, okay? That's what an asymptote is. Did everyone label that on there too? Okay. Everyone labeled it, and we're moving on to the next little part. I'm going to put that on the sideboard now. The sidewall, that is. All right, next.
You can barely see it here.
Okay, left phone, more right. Get done faster. Now, the rational function can be transformed by using methods similar to those used to transform other types of functions. Look at the bottom of this page. This is all you need to know about transformations, okay? Similar to what we did with quadratics and other functions, okay? Now, let's talk about this. Vertical shifts. Now, I'm going to write on this. I know it's kind of small, and I'm sorry, but hopefully you can try to see it. Now, vertical shift is the k value, okay? So plus k moves it up, minus k moves it down. So everyone should be writing this now so they don't have to be crying when I move to the next slide, right? All right? Now, let's draw a picture of this. By the way, the more I have to do that, the more, you know, we have someone else come over here who y'all are very big fans of. All right. All right, well, so if you're on task, I won't knock on her wall. She won't come over here. All right, so here we go. Whoa, 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 chill. I said chill.
Chill.
Chill. All right, so here we go. So our picture, this is the original rational. This is the original rational. So if we shift it up vertically, you're going to have to write both of these. See these two little curves? You have to move them both up, okay? I know this is weird. It's one function, but it's got two curves, okay? So I'm going to move it up. So draw the same thing a little bit further up. And I know that's ugly and it's kind of hard to make out, but these two have moved up to make these two. These two, shift them up, okay? So if you look at the original on the other side, or yeah, sorry, right there. That is it. When you move it up, there was nothing here, you know. Okay. Yeah. Good question. Now, here we go. Next one. It's on the same slide, so if you're taking a brain break right there, you can still follow along, everybody. Horizontal, okay, is going to be H. Go ahead and put lies. The lies, okay? So here we go. If H lies, what normally looks like it would be left is really going to be right. What normally would look like it's going to be right is going to be left. So here's what I mean. If I have a negative H, isn't negative usually to the left? But since we know H is a liar, it's going to actually be to the right. So minus H is going to be to the right. Yeah, juke. Plus H, A, isn't positive to the right. Yes, but H is a lie, so it's going to actually go to the left. Okay. Here's another way to remember that. Okay. Now I don't want to speak of terrible things, right? But if you think of H being on the bottom, I can think of a place that is below in the bottom where things are all backwards. It's the HE double hockey stick place. All right. So you think H is below. And everything is opposite. All right. Left and right. Yes. Okay. H for horizontal and heck. Okay? Yeah, you can say it. Whoa, whoa, whoa. All right, so check it out. Now, we're going to draw it again. Ready? I'm going to put a little, dang it, that's terrible. Try that again. It's really hard to draw these little tiny graphs. Okay, so go ahead and draw the original rational, and then you need to shift it over to the right. So it's going to look the same thing, kind of moved over here. All right, I know that's weird, but those, you want me? These two shifted to the right to make these two. Shift over, okay? Now, reflection is going to be, the reflection is going to be negative A. The number on top is going to be a negative, okay? Negative A. So the number, if you look at this thing down here, if the number on top is a negative, it's going to flip it, reflect it. Now, watch me draw this real quick because it's going to be, it's going to look ugly at the end. So I have my original that looks like this. Now, when you flip this, it's going to be in these other two blank spaces. Like this goes down here, this goes up here. Okay, so when you flip it, it's going to look like it's all filled in. There we go. Yeah, kind of. Or pinata. Now, that's a reflection. Again, watch my fingers here. The bottom left, top right flips to make top left, bottom right. Flip, flip. Okay. Okay, vertical stretch or compression. Now, this one, okay, if A is greater than, if A is greater than 1, that's a stretch. If A is between 0 and 1, that's a compression. I'm running out of room here. So if 1 less than A, which means A is greater than 1. 0 less than A, less than 1. So stretch will make it look like it's getting narrower, and then compression will look like it's getting wider. Okay. So what can you do? You can just draw the original. Hold on. Draw the original, and then you can draw like a stretched out version of it. This is so hard to draw on here. Whatever. You draw another one on top of it that's more stretched out, okay? Okay, I'll leave that on there for a second, but we got to move to the back. The drawing, it's supposed to look, hold on, it's supposed to look more stretched out. So it would look, yes, for now. We'll show some examples when we get to that, but this is just like a quick little something. And sorry that it's ugly. It's hard to draw on a PowerPoint, I've learned. No. Okay, here we go. Next one. Is anyone going to cry when I move to this next slide? All right, I'm going to leave it over here. Okay, real quick. If you're done with that, flip it to the next page. Next page. Here we go. Now, actually, I should say, this was at the bottom. We already referred to this. This is what we're going to keep referring back to for our transformation. H is on the bottom, the H. K is off to the right, and then A is on top. Now, all we're caring about today is H. What happens if you change H? Okay. Now, first I want you to draw step 1. Graph the parent function. What is the parent of all rational functions? It's that original one we saw in the front. So everybody, go ahead and draw this blue graph. Okay. So we're on the back on number, what's it called? You want to flip it over? Go ahead and draw that. Draw that blue graph. Now there's another name for this. It's hyperbola, but we call it hyperbola, or same root. Hey, over there with the headphones, you know. Okay. Now, here's the deal. We said H is down in on the bottom. So, what number do you see there on the bottom? Number. Yeah, so you see a +2, right? Now, we said on the bottom, I'm going to say it again, on the bottom is a lie. So, instead of +2, what should I write? What is the opposite of a +2? -2 or -2, okay? So is everyone with me? The bottom is the H and it's a lie. So we have to put the opposite sign. So we're going to put H equals -2, okay? Now, once you got that, step 3, graph the new function. So what I want you to do is take that blue thing and I want you to move it 2 to the which way? Left, and we're going to write that down up here, left 2. Why? Because +2 normally means right, but it's a lie, left 2, okay? So go ahead and redraw this picture 2 to the left. It's going to look like this in the red. You see how they put like the dashed line right here, and then they just redrew it, okay? Okay, I want you to draw this, the red one. So the blue one first, and then the red one is shifted 2 to the left because on the bottom is a lie. It's horizontal. Yeah, go ahead and put that dashed line so you know where the asymptote is. Asymptote is the dashed line that you can't cross. It's like a limit. I hear you. Okay, so step 4. Now, everybody, I'm going to ask you this on the next one. I want everyone to know this. When I ask you for an equation of a vertical line, look right here, look at me, okay? Vertical line goes up and down, right? What axis does it hit? What is this axis? Thank you, X. Everyone agree? Vertical hits the X. So if it's a vertical line, it's always X equals a number. So go ahead and put X equals for step 4. X equals. Vertical lines are always X equals. And then step 5, for horizontal, we always put Y equals. Okay? Cool. Now, what does X equal? Where is this vertical asymptote? So, what do you think? What is this X value right here? Feel free to answer. What is the X value at this vertical asymptote? -2. Okay. So what is the equation of the vertical line? X equals -2. Okay. So anytime I ask you for a vertical asymptote equation, you got to put X equals and just tell me where does it cross. Right there. For horizontal asymptote, it's going to be Y equals. Now check it out. No, because it crosses right here at 2, right? So the gap where it doesn't cross horizontally is right here, still on the axis. So what value is that? 0, okay? See how the red and the blue, they don't touch 0 at all. They get close, they don't touch it, okay? So when the axis is what you're talking about, you got to put 0, okay? Now here's the trick. This is not too bad. If you know the asymptote for domain and range, this goes forever to the left. This goes forever to the right. It goes forever up, forever down. The only place it doesn't touch is the asymptote. So literally, for your domain, you're just going to put X is not equal to, does not touch, what value? What value does it not touch again? -2. Do you see how the equation of the asymptote and the domain are related? Okay, so look right here. Step 4, that's the asymptote. Step 6, the domain is just not that. You see how I'm just crossing out the equal sign? Okay, so vertical asymptote, not equal to that. Okay, so for the range, similarly, if I know the horizontal asymptote is at 0, the range is just Y does not equal 0. That means all the values of Y work except for that asymptote. So I know it's kind of dense and kind of, But let's do one more. One more. Ready? Draw the parent function again. Same parent function. Always the same parent, right? Same originator. Don't do that. Don't do that. Please sit. Did everybody draw this on number 2? Yeah. Did you though? Because I see that you didn't.
No.
Okay. What? Oh. Oh, that. There you go. Okay. So now, I know on mine it's small. Yours might be bigger. What is the H value? So H is on the bottom. What number do you see there? I see a -4, so the H is opposite, +4. Go ahead and put a +4 up there, and that means it's going to go to the right 4. Again, opposite of negative is positive, positive is to the right, right 4, okay? Now, we need to graph that. It needs to move 4 to the right. Now, it'll look like this. So go ahead and draw, if you haven't drawn the blue one, draw the blue one, but make sure you draw this red one. It is moved 4 to the right, over here, okay? So we go to the right 4. Now, the equation for the vertical asymptote. What do I always put for a vertical asymptote equation? Thank you so much. Oh.
No, I do.
All right. X equals what? X equals what? +4. Okay. Now, step 5, horizontal is always, y equals, thank you, y equals what? It did move up or down, so it's still 0. And then if you look at the one right above this, all we do for domain and range is say it's not equal to this and it's not equal to this, right? You just take this and slash it. So what should I write for domain? Very good, because it touches everywhere except for the line that it doesn't cross, okay? Now, go ahead, make sure you have this written down. Keep this because we're going to be using it tomorrow, okay? Let me freeze this real quick.